In this presentation, we will consider one question related to loops. So let's get started. How many times will Hello World be printed in the below program? This is the program available. We need to identify how many times this Hello World will be printed on the screen. These are the options available. Is it option A, 10? Is it option B, 11? Is it option C, infinite? Or is it option D, compile time error? I will encourage you to pause the video for a while and try to answer this question on your own. As you can clearly see, I initialized this variable with the value 1024. And you can see there are weird looking expressions written inside this for loop which we haven't encountered before, right? Now we know that before this colon we have to write initialization step. After this colon we have to write condition step, and after this colon we have to write increment or decrement step. But this is totally changed. Before this colon we haven't mentioned any initialization step at all, because the initialization is done before this for loop already. So there is no need to initialize this once again over here, right? After this colon there is one condition step, but instead of writing one condition statement like I greater than equals to 0 or something like that, we have just written I. And after this colon, instead of any increment or decrement step, we have mentioned I greater than equal to 1, which is nothing but a right shift operator. Now my question is how this program will run. It is not very difficult to understand this program. Let me tell you one important point. It is not always necessary to mention all the 3 steps inside the for loop. We already know we have to mention 3 steps: initialization step, condition checking step, and then increment decrement step. Here we skip initialization step. There is no problem in skipping the initialization step, but you have to mention this colon over here. If you didn't mention this colon, then compiler won't be able to recognize that the next step is an initialization step or is it a condition checking step. So it is very important to mention this colon. You can definitely skip the steps, but you have to mention these colons. You can also skip this step, but you have to mention this colon again. This is what we need to understand. Okay? As we did initialization in the first step itself, there is no requirement of initializing this particular variable again, right? Therefore, we simply skip this step. Let's try to execute this code. After initialization, that is I equals to 1024, we check this condition I. Now this I is replaced with 1024, right? Now we already know that condition checking step will always produce the answer as true or false. Now 1024 is a number other than 0, and we already know that number other than 0 is always treated as true. Therefore 1024 will be treated as true, and we come inside this for loop and print hello world on the screen one time, right? After printing this hello world on the screen, we come to this step, that is I greater than equal to 1. We can write this expression as I equal I greater than 1. This is a right shift operator, and we know this operator will shift all the bits towards right by 1 position. This is what we already learned in the previous lectures. Now we know what is the value of I. Right now, value of I is 1024. We can write this value in binary as 10000000000. There are total 11 bits in this particular representation. Now what does this right shift operator do? It will shift all the bits towards right. When it shifts all the bits towards right, this bit will get truncated and this position will get vacant. So the output becomes 01000000000. As this position is vacant, this will automatically get filled with 0. We already know this. The equivalent decimal representation of this binary representation is 512. So the output produced by I greater than equal to 1 is 512. After that we know we check the condition. 512 is a value other than 0, therefore it will be treated as a true value, and hence this particular output will get printed, hello world. After printing hello world, we again come to the step, that is I greater than equal to 1. Again we shift all these bits towards right. So the output is 001 00000000, and the decimal equivalent of this particular representation is 256, right? Again 256 is not equals to 0 and hence hello world will get printed. Up till now hello world is printed 3 times. If we observe carefully to these bit patterns, we can clearly see that when this bit, that is 1, is at this position, then hello world will be printed 1 time. When 1 is in the second position, then hello world will be printed 2 times. When 1 is in the third position, then hello world will be printed 3 times. Now we can clearly observe that when this 1 reaches at the last position, that is at 11th position, then this means up till now hello world is printed 11 times. Because this one is at 11th position, this means that up till now hello world is printed 11 times. When we again apply this step, that is I right shift operator 1, then 1 becomes 0 after that, right? When it is 0, then we check the condition. As 0 means false, therefore we come out of this loop and simply return 0. This means we come out of this loop and we had successfully printed hello world 11 times. Now we already know the answer. It is option B, 11.